Hey everybody, I wanted to take a little bit of time and talk to you about what's going to be on exam 3. It's coming up and there's going to be 3 topics on it, okay, on the exam. The first one is going to be, let's see if I can do this, okay, the first one is going to be thermodynamics, okay. The second one is going to be electrochem, and the fourth one is going to be nuclear chemistry. Okay, so I took a second and wanted to point out some resources that you can use to help you get there in Schoology. Okay, so this is the class here, right here, that we have, and I would go to, let's see, I would go to lecture 10, I guess. So lecture 10, the point is that we are going to be studying those enthalpy reactions, products minus the reactants, and Gibbs free energy, and relating that back to the equilibrium constant. Okay. Now, within each of these videos, there's some sample problems that you can look at and how to do that. But maybe you would also like to have your a PowerPoint, and so in the previous lecture, the first time that we talked about it, it's right here. So thermodynamics, the PowerPoint is right here, and I'll open that up just to make sure that, again, so that you can see what the heck is going on. And so this is the PowerPoint, and this stuff was all covered before, but the things where we're going to start is, let's see, we did calorimetry. Okay, we did that stuff. Okay, and we did Hess's law. That was the last thing that we did. Okay, and so we're going to start with enthalpy of formation. Okay, but where we're really going to start probably is here with, oh, I don't know what just happened, but that was cool. We're going to start with products minus the reactants, okay? And so when you go through here, you'll see that there's a sample problem, products minus the reactants, and then here's another sample problem, and all of those are in the videos for lecture 10, okay? And then we're going to talk about entropy, and keep in mind that you can predict entropy based on the states of things and based on about how many elements there are, so I'd review that. These make really good multiple choice questions. And then entropy can also be determined based on products minus the reactants. And again, there's some sample problems you can go over. And then Gibbs free energy is the measure of spontaneity in the reaction. Okay, and then we spent a lot of time in class going over problems where we need to worry about the sign of delta G and the sign of delta H and how it relates to that. Okay, and then the last thing here will be the relationship of delta G, the spontaneity of the reaction, to delta K, or to delta K, yeah, right, to the equilibrium constant, capital K. So that's the first thing. Now if we look back here, electrochem, there's everything that we did for electrochem is going to be on there. Okay, we're not splitting that into sections. So I'm going to come here and I'm going to go back to the section. So if you look in lecture 9, okay, or sorry, lecture 11, electrochemistry, you'll see all of these videos. Okay, and so again, reviewing the PowerPoint, so you can go see which lecture you want to, or which part of the lecture you want to go to. Okay, we talked about redox, okay, and what that means, and what's being reduced, what's being oxidized, that sort of thing. One of the focuses in terms of electrochem is going to be balancing reactions. Okay, so not only are we going to worry about balancing uncatalyzed reactions, but we need to balance acid catalyzed reactions and base catalyzed reactions. Okay, and within each video there is definitely examples of doing that. Okay, and again, my advice for this is to, try to do it on your own, when you do it on your own, then you can go back and go through step by step where there was going to be a problem. Okay. And then I can guarantee you that you're going to have to be able to draw and label an electrochemical cell, okay, and calculate the cell potential. Okay, I will definitely give you the table of reduction potentials, and that way you have it, and then you can do that. So, and then the last thing that you're going to have to do is relate cell potential to spontaneity. And spontaneity, then, remember, spontaneity can be related back to delta G, and there's a relationship between delta G and the equilibrium constant. So you're going to go from cell potential here to the equilibrium constant. Okay, so there's a lot of neat, crazy things going on. Okay, and then there's a whole bunch of blank slides after that. Okay, but there is what you are going to need to do for electrochem, and then maybe the most straightforward of all the topics was the most recent one in nuclear chem, and the nuclear chem is just 4 parts, but again, I'll pull up this. Excuse me. Okay, and so here we have the nuclear chem PowerPoints. We're going to talk about, you're going to need to know alpha, beta, gamma, and you're going to need to know the other 2, which are on the bottom here. So positron emission and electron capture. And you're going to have to be able to balance these reactions. And we spent a lot of time in class balancing the reactions and knowing what's going on, and making sure that the atomic number here on the bottom and the mass number here add up. So that's where you're going to pick up now. Maybe some advice if you want to look at stuff. If you look in the sample problems, I have a lot of sample problems here in how to solve all of these. Now, use this in conjunction with your book, because I go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sample problems, and there are sample problems also embedded with each of the videos that should help you out, kind of know, it helps you know what kind of questions I'm going to be asking. Okay. So let me just double check. I actually have the test pulled up here, just so we know what the heck is going on. Okay, so there's radiation, balancing, radiochemistry, radioactive decay questions, balancing redox reactions, in acidic solution, uncatalyzed solutions, basic solution, calculating cell potentials. Okay, that's in there. Drawing a cell potential, and then also multiple choice, just like we've had. So there's all sorts of things. I did notice as I was going through that there weren't necessarily as many explicit examples here in the thermodynamic section. So when we look up the sample problems, there's really only one enthalpy sample problem. So over the weekend I'll post a couple more so that you may be able to go through and look and see how those work. Enthalpy, Gibbs free energy, delta G equals delta H minus T delta S. Okay, so I think that so that's it. The most difficult stuff here is kind of out of the way, so that's always good. And so there we go. Have a great day, and everybody stay out of trouble.